right, so as I said, we're going to be using an Arduino Mega for the rest of this course as our microcontroller. And we're going to cover just some basics about the hardware itself. So the Mega is a microcontroller board. It's sort of aimed at hobbyists and people getting into microcontroller programming. There is as we just saw, a coding interface, what's called an IDE, an interactive developer environment, which will allow you to write your code, upload it to the Arduino, and it has some troubleshooting tools. And there is actually a pretty good set of documentation and tutorials and an active forum on the Arduino website where if you're having difficulty, you can find some guidance. So as I said, this is the microcontroller that we're going to be using. And what a microcontroller is just a small integrated circuit that is a computer that has a set of instructions that it can execute. So it's a processor. It can receive input and output. It has some memory to store information, and a number of input and output pins for doing different sorts of operations and for interfacing with stuff, with sensors and other types of input and output. Specifically, it is what you would call a development board. So if you were wanting to make a commercial product, you probably wouldn't ship out the board itself, but you would instead design a PCB with just the microcontroller and whatever else you needed. But this development board is sort of, here's a general set of inputs and outputs that are in a relatively easy way to connect, and so that you can do stuff like prototyping and trying out different ideas. It sort of gives you the minimum hardware for connecting your USB and getting access to all the input and output pins, and for doing any sort of programming. So there's actually a number of different boards, all made by the Arduino. We're in particular going to be using the Mega, which is this one right here. Depending on how old yours is, there may be a slightly different version, but it's functionally the same. You have another one called a Nano, a Teensy, and Uno. These are all like smaller. In particular, this Nano is very small. It's like about the size of this area in here. They all have slightly different capabilities, but we've found the Mega is sort of the general good for a baseline for a number of leads, especially for this course. Arduino is by no means the only architecture. Another very popular one is a Raspberry Pi. That is a much more robust system that has a full-on operating system running on it. You can hook up monitors to it. Another one is a BeagleBone. And then finally, the previous microcontroller that we used was what was called a basic stamp, which was very useful, but also very basic and getting pretty outdated. So here's all of the major specs for the Mega. The important things to note here is the operating voltage is 5 volts. So that means all of the logic on the pins works on a 0 to 5 volts. The analog input pins work on a 0 to 5 scale. However, the input voltage, i.e. the voltage that you can power it, is recommended to be 7 to 12, but 6 to 20 should be okay. So, and you usually power it either through this barrel plug here, or if it's plugged into the USB, it'll actually draw power through the USB. There are 16 analog input pins. So you can see A0 through A15 here. That is a 10-bit ADC. If you don't know what a ADC is, we will be covering it later in the course. And then you also have some specs on the maximum current through your I/O pins, which is something you want to be careful of because you don't want to burn these pins out. So as I discussed, normally you power it with a AC adapter that you plug into the wall and into the barrel plug or through the USB. You can also provide power through this V-in pin. But one thing that is important is there's no protection on that, and you should be giving basically exactly 5 volts there. And actually, in the second semester, when you work on the BalloonSat board, that is how it is powered from the BalloonSat board. But the BalloonSat board has like overvoltage and direction protection, so you don't damage it. You also have a 5-volt output and a 3.3-volt output pins on there. Basically designed for powering any expansion boards that you would have on there. One important thing to note about the Arduino is the memory that it has on board. So you have 3 basic types of built-in memory on the board. You have the flash memory, which is where your actual program is. You have your RAM, SRAM in this case, which is where all of your variable values are stored. And then you have EEPROM, which is can be used for sort of like a hard drive for permanent storage. One important thing to note about this SRAM is if you lose power, that all goes away. Whatever values were stored in there are lost. And the flash memory is overwritten by uploading programs. So if you lose power, basically it starts the program over from the beginning. So you have a whole bunch of interface pins around the outside of the Arduino. They're labeled and they all do different things. Some of them actually have multiple functions, but basically these 3 sets of headers, you can see the traces go and connect to these very, very small pins on the actual microcontroller. They give you access to the power, the ADC pins, digital pins, and a number of serial inputs and outputs. So like I said, you have 16 ADC pins that will basically allow you to read in a voltage at those pins between 0 and 5 volts and convert it into a 10-bit number. Obviously, once you read it in, you would then store it somewhere in memory, or maybe write the value to the EEPROM or to an SD card like we're going to get out, discuss later. Then you have the rest of the pins are pretty much all different types of digital input and output. There's 54 of them all together. What's important to note is that these don't have variable output. You can only turn them on and off. Additionally, there's a number that have that are dedicated for specific functions, like serial ports or interrupts, or what's called pulse width modulation. We'll talk about all of those individual things later. So like I said, you have UART, and there's actually 4 sets of these IOs on the Mega. So they come in pairs. There's a transmit pin and a receive pin. So you send out signals on the transmit and you listen on the receive pins. Fairly self-explanatory. And in particular, they use what's called TTL logic, and that basically just is a standard of, hey, how high of a voltage does it have to be on? How low of a voltage does it have to be off? There are dedicated pins for what's called the SPI protocol. That's just another type of communication, and there's 4 specific pins. There's a master input, slave output, master output, slave input, and a serial clock pin and a chip select. So we'll cover that also as well. And then there's also pins for another protocol, which is called the I2C or the I2C. And that has a data pin and a clock pin. Again, we'll cover that more in detail later. And then finally, there's these pulse width modulation pins. And basically, those are used to give you a sort of analog output. You basically have a pulse signal that is on for a certain percentage of the time. So with a fairly simple circuit of a capacitor and resistor, you can then make that into a analog output. So one of the things that's nice about the Arduino is it has a number of expansion boards that are built on a standardized footprint. So this allows you to either purchase or design your own boards that you can then just stack on top. These are called shields, and they're designed so that you can just, like I said, stack them one on top of each other. And in particular, the Megasat that we're going to be using in the second semester is a shield. So what you see here is the Arduino is actually on the very bottom, and then this larger board is the Megasat, and then on top of that you can see the this is the GPS and SD card shield that we're going to be using later. So in particular, if you just want to play around, as part of the Arduino website, there's what they call the playground that just has little snippets of sample code, little short projects that you could work on your own if you wanted to. And like I said, the forums there are pretty active, and there's a lot of knowledgeable people there if you're having issues. So just a few common mistakes that might happen. If that supply voltage gets too low, the 5 volts may not be all the way up to 5 volts, which now if you're trying to interface with things that are assuming that to be at 5 volts, you might have issues. Also, always check your data sheets, make sure you're actually plugged into the correct pins. Something that's very common along that lines is to have your transmit and receive for your serial pins to be flipped. And then programming, you need to make sure you've got your correct version of libraries, you're calling the appropriate pins, and just more general coding errors.